Today we will be solving 0620 February-March 2025 paper. You all must be having an exam tomorrow, so all the best. Don't forget to do this paper as it's the most recent one. Okay. Inks contain different color substances called dyes. Okay. A student used chromatography to investigate the color dyes contained in 6 different inks. The student drew a baseline on the sheet of the paper. Always remember that this baseline must be drawn with a pencil. All right, with a pencil. Sorry, you have to deal with my handwriting. Okay, the reason for this is that pencil is insoluble, so it won't interfere with the result of the reaction, whereas ink is soluble and it interferes with the result of the reaction. Please remember this as it is commonly asked. Okay, the student then places the spot on each ink of the chromatography paper and set up the apparatus as shown in figure 1.1. The student made 2 errors. So as you look at the chromatography paper, you can see that the first error is that these spots are not placed on this baseline, right? This is the baseline and the spots must be placed on the baseline over here, right? And the second mistake is that this is the solvent line, right? It should be touching the chromatography paper. Yes, it should be below this baseline, but it should be touching the chromatography paper. So here we see the spots of ink must be placed on the baseline. The student places them below the baseline. Alright, and the chromatography paper is not touching the solvent. Next, state the name of the equipment used to rub baseline on chromatography paper. We already discussed pencil. Now, the student corrects the errors and then carries out the chromatography. The chromatogram in figure 1.2 shows the student's results. So they have asked, identify an ink which could contain only one colored dye. One colored dye means one spot, and you can see one spot here for the yellow ink and one spot here for the blue ink. Rest all have like green has 2 spots, orange has 2 spots, purple also has 2 spots, black also has 3 spots. Okay, now moving on, deduce which ink can be mixed with the blue ink to make the black ink. Okay, so mixed with the blue ink to make the black ink. All right, let me explain you all this. Okay, so we'll just change the color. All right, so this is the blue ink. It has 1 dye, right? Whereas the black ink has 3 dyes. So blue ink has 1 dye. It needs these 2 dyes, and it can get it from orange. So blue and orange together, blue and orange, right, will make the black ink. Okay, so you will write orange because they've already given it's mixed with blue, so you write orange here. Deduce the color of 1 dye that is contained in all of the 3 of the orange, green and black inks. So you will see here that let me erase all this. Okay, you will see here that yellow is the dye. Yellow is over here, and they have asked for what colors? Just give me a minute. They have asked for orange, green and black inks. All right, so if you see over here, this yellow is there in orange, so they're in green, and it's also there in the black. So yellow is the answer. Okay, now moving on to the next question. The student investigates the temperature change. This is a very common question. Please understand this very well. A student investigates the temperature change when aqueous copper sulfate reacts separately with 2 different metals, zinc and iron. The student does 2 experiments. Experiment 1, use a 50 centimeter cube measuring cylinder. Okay, note that they have used a measuring cylinder, so you can use a pipette or beard, which is more accurate. So this can be an error. To pour 30 centimeter cube of aqueous copper sulfate into 100 centimeter cube beaker. Use a thermometer to measure the temperature of the contents of the beaker. This is the temperature at time is equal to 0 seconds. Add 3 grams of zinc powder to the beaker. At the same time, start a stopwatch. Using the thermometer, continually stir the mixture in the beaker. Measure the temperature of the mixture every 30 seconds for 210 seconds. Empty and rinse the beaker with distilled water. Repeat experiment 1 using 3 grams of iron powder instead of 3 grams of zinc powder. So here what they are doing is that they are changing the metals. They're first using zinc, then iron, and they are checking what is the temperature change when they react with copper sulfate, and they're measuring the temperature. So this is also again a very common question, temperature change. So you should know how to read this. Let's do this together. So see, 31. You can divide the scales. They're total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So you divide it 1, 2. So when you divide by 10, you realize that each scale is 1. So 31, 32, 33, 33.5 will be over here. 33.5. Okay, then moving on to the next one. Okay, first let's find the temperature change. They said with time 0 you have to find, so 33.5 minus 24, you will get 9.5. All right, moving on to the next one. We see here that it is 35, 36, 37, 38. It's 38, so 30, sorry, my bad, 38 point, 38.0. So the reason we add a 0 is that we need the same decimal places in all the columns. So this is how you will continue doing and reading the scale. Okay, so this is all the values you will get when you read from the temperature and subtract from the 0 reading. Remember that this reading, what you get, you have to subtract it from this and this from this. For each row, you have to do the same thing. All right, okay, now let's move on to the next part of the question. Okay, so the next question is a graph. You need to choose a good scale. So this is how your graph will look like. I had drawn it for you all. So make sure that it is a line of best fit. My line is not going so well. I tried to do it online. So please make sure that's a line of best fit and it passes to as many points as possible. For the next part, you need to extrapolate the curve for experiment 1 on your graph in figure 2.1 to deduce the temperature change since time is equal to 0 seconds. In experiment 1, after 240 seconds, show clearly on figure 2.1 how you worked out your answer. Okay, so you check where 240 is and then you draw a line till there and then you check where it cuts the y-axis and then you get your value. It can have a range of values depending on your graph. Okay, so now moving on, state which experiment 1 or 2 is more exothermic. Explain your answer. So if you go back over here, you can see that for experiment 1, you have a greater change of temperature over here, okay, and over here, all right. So over here, you have a lesser change in temperature in this column. All right, so that's why the answer is experiment 1. Temperature change is greater for same time interval it's compared over here to experiment 2. Now, to predict the temperature of the solution, experiment 1 after 3 hours, that has to be equal to room temperature. This is also a very common question. They try to check if you know it will equate to the room temperature because it loses heat to the surroundings. Next, explain why copper container instead of the beaker would not be an improvement in this investigation. The reason is that copper is a conductor. It will absorb heat and cause heat loss to the surroundings. Because you all have studied metals are good conductor of heat, well, that's what we have to write it here. Describe the changes to the apparatus that will improve the results of this investigation. For change, explain why it will improve the results. So it is an explain, you need to write it in detail. Use a polystyrene cup rather than a beaker. The reason is that polystyrene cup is an insulator and it reduces heat loss to the surroundings. This is very important. Always remember this because you can write this for any temperature question related to temperature. Okay, next, if you see over here, another improvement we can do is that I told you they used a measuring cylinder, right? So what we can do instead of using a measuring cylinder is to use so we can use a beer to measure the volume, more accurate than measuring cylinder. Remember that measuring cylinder is less accurate, though it gives quick results and is convenient, but burette is more accurate and it gives slow results and is not inconvenient, but these are the advantages and disadvantages. Now moving on, next we have chromium nitrate over here. We have chromium chloride over here. So we have to check the tests on the solution A, which is chromium chloride. So the strain divides solution A into 3 approximately equal portions. Okay, complete the expected observations. So first of all, he adds aqueous sodium hydroxide dropwise until it is in excess. Okay, remember this. So if we go down and check sodium hydroxide and remember that ours is chromium chloride. So if we go down bottom to the table which we are given, you will see here that in chromium, when you add sodium hydroxide, a green precipitate is formed which is soluble in excess. So all you need to do is copy down that in the answer. So you can see here green precipitate soluble in excess. Next, you add So to the second portion of solution A, the student adds 1 centimeter cube of dilute nitric acid followed by a few drops of aqueous barium nitrate. Again, if you go back to the table, oh my god, this is so annoying. Okay, if you go back to the table, you see dilute nitric acid with aqueous barium nitrate is for sulfate, and we have chromium and chloride here, so chromium and chloride, right? Yeah, chromium and chloride, so there'll be no change. Don't write no observation or anything. Learn the wordings of the mark scheme. It's always no change. It's better to stick to the wordings of the mark scheme to attain full marks. To the third portion of solution A, the student adds 1 centimeter cube of dilute nitric acid followed by a few drops of aqueous silver nitrate. Again, when you go back to the table, I'll tell you where you find this over here. Here. Dilute nitric acid with aqueous silver nitrate, white precipitate. So you just copy this, white precipitate. You can also write white PPT. It depends on you. Better to write the full word. Okay, next. They carry out a flame test on solid B. Okay, the student's observation for solid B. Okay, carry out a flame test on solid B. Red color flame. Again, get back to your table. You see red color flame is for lithium. So you can write it up over here that it's a good technique to do this. It is lithium plus. Okay, moving on to the next one. Dissolve the remaining solid B in distilled water to form solution B. Divide solution B into 3 proportions, blah, blah, blah. Okay, to the first portion of solid B, solution B, add a few drops of acidified aqueous potassium manganate. Okay, again, go back to the table, find this acidified aqueous potassium manganate. Here you see sulfur dioxide turns acidified aqueous potassium manganate from purple to colorless, so it must turn to colorless if SO2 sulfur dioxide is present. But when you come back over here and see, they are saying that it's a pale purple solution, so this contains no SO2. Sorry, okay, SO2, better. All right, next, test 3 to the second solution of, so the second portion of solution B, add about 1 centimeter cube of aqueous sodium hydroxide. Solution remains colorless. Okay, they are trying to tell you here is when you add sodium hydroxide to any metal, okay, I'll just tell it verbally. When you add the sodium hydroxide to any metal, you are going to get a precipitate. Like if you do any cation, if you go back over here, you will see when you add sodium hydroxide to all these cations, you will get a colored precipitate. But no colored precipitate is formed. What they're trying to tell us here is that there is no metal cation. But to the next, in the next one, what they do is warm. Okay, in the next test, they are telling you to warm the product of test 3 and test any gas given off with damp red litmus paper. Damp red litmus paper remains red. If you go back again to your table, you will see the talk about litmus paper here in the gases. That damp red litmus paper turns blue. So here, all they're trying to do is test for ammonia when you add sodium hydroxide, and then ammonia is produced on warming. But the thing is that there is no ammonium, which is why the litmus paper remains red, because no ammonium is formed, so there is no ammonium basically. When there's no ammonium, ammonia is not formed. I hope you got my point. Okay, to the third portion of solution B, add about 1 centimeter cube of dilute nitric acid followed by a few drops of aqueous baying nitrate. We saw this before as well. This was, so see, we see this here. This is for the sulfate. Add dilute nitric acid with aqueous baying nitrate, white precipitate. So this tells us that SO42 minus is present. SO, wait a minute, SO4 to minus. All right. Now, how do you carry out the flame test? This was asked in the 2023 specimen paper as well. Make sure you do it very well. You use a clean wire. You can use a nichrome wire, okay, and then you dip it in the sample or a sponge soap in solution. So basically, if you take a wire, you dip it in the acid to clean it, or you then after that you dip it in the solid sample. Then you put it in the blue roaring hot flame. You can write any of these 3 words, and then you put the wire into the flame, okay, and then you observe and record the flame color produced. Okay, so make sure you know all these steps. Now, identify the ion that is tested for in test 4. We saw it over here that they were checking if any gas was given off when we added sodium hydroxide, and then they warmed it. Okay, warmed is the main thing. When you go back to the table, you will see that is for ammonia. Next, identify 2 ions that are present in solid B. Till now, we only deduced 2 ions. There's no SO2, so there's Li plus and SO42 minus, sulfate, lithium, and sulfate. You can write it in any way. You can either write the name or the symbols. Okay. Now this question 4, metal spoons can be electroplated with silver. Describe how a metal spoon can be electroplated with silver. Include in your answer how you determine the mass of the silver. This is very important. Read your question really well. Okay, electroplated on the metal spoon. So you should always remember, the metal spoon is the metal spoon is the one which has to be electroplated. So it has to be at the cathode. This is something you all must remember, and with which you electroplate is the silver. So silver must be at the anode. Alright, this is something that everyone must be knowing. Now, include in your answer how you could determine the mass of the silver electroplated on the metal spoon. You are provided with solid silver nitrate. Okay, so this will form the solution of the anode. This will form the solution of this will form the electrolyte actually. Okay, and a metal spoon, a piece of solid silver, distilled water, and common laboratory apparatus. You must include the diagram in your answer. All right, it's a must. So basically what you'll do, you set up a cathode and then the power supply, which is very important, the positive terminal connected to the positive anode. And positive anode is a silver rod, as we discussed before. The cathode is a metal spoon. Alright, and silver nitrate solution. So clean the metal spoon with using sandpaper. You must clean it, alright, then then you measure its mass. I think I've written it later. Alright, you measure its mass after cleaning with the sandpaper using a top band balance. Okay, and then you dissolve silver nitrate. You basically add distilled water in it and dissolve. Alright, in distilled water to form an electrolyte. Exactly. Set up the circuit by switching on the electricity. The power supply, basically, whatever. Okay, silver spoon is the anode, as we discussed. Again, the positive electrode, and metal spoon at the cathode, the negative electrode, which has to be electroplated with the silver rod. Remember that the anode solution must be used as the electrolyte. Like silver solution is used, that is soluble. You must learn all the solubilities. You can refer back to your syllabus. They're all mentioned over there. Otherwise, mention in the comments, and I will send you. Alright, so to rotate the metal spoon, you must keep rotating the metal spoon. The purpose of this is that all parts of the metal spoon are covered with the silver rod. Okay, and remove the metal spoon after. You can set a timer, right? You can mention about the timer if you want that, set it for 5 minutes, 10 minutes. Anyways, okay, remove the metal spoon after that and wash and dry it again with the sandpaper, and weigh the metal spoon before electroplating. This, I mentioned it here, it should have been mentioned before. Anyways, and then weigh again after electroplating. Mass gain is equal to mass of silver deposited. With this, we come to the end of the paper. I hope you all have understood everything. All the best for your exams. We wish you all the best and take care. Goodbye.